So let's look at problem number 56. An investor has $24,000 to invest in bonds of AAA and B qualities. AAA bonds yield an average of 6%. The B bonds yield 10%. So right away, if we look, we're trying to maximize our return. Our return function is 6% of the AAA. I'm going to let X equal amount of money invested in AAA bonds, and Y is the amount of money invested in B bonds. All right, so R is 0.06x plus 10% is 0.10y. We're trying to maximize that return and subject to some constraints. The first constraint is x plus y is 24,000, less than or equal to 24,000. So because I don't have to invest all of it, x plus y less than or equal to 24,000. And the second constraint, the investor requires that at least 3 times as much money should be invested in AAA as in B. So x is at least 3 times more. So if I subtract 3 times y, it should be greater than or equal to 0, because x could be more than 3 times more. So if x is 30 and y is 10, then 3 times 10 gives me 30, and the subtract gives me 0. But if x is 40 and y is 10, then 40 minus the 30 gives me a number greater than or equal to 0. So then I have my x greater than or equal to 0 because I'm going to invest something, maybe nothing, but it guarantees me in the first quadrant, and it makes sense. I'm not going to invest negative amounts of money. So this problem only has 4 constraint equations. So x plus y less than or equal to 24,000. Let's do a t for that one. X and y. Obviously 24,000, 0, and 0, 24,000. 24,000, 0, and 0, 24,000. X minus 3y, just to keep it in the thousands. We can do 24,000 for x and 8,000 for y. So 24,000, 8,000, and 0, 0. 0, 0, you get 0 greater than or equal to 0, which is a true statement. So 0, 0. So let's do let's go by 2,000. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That's my over 0 up 24,000. 0, 24,000. And same thing over here, 24,000, 0, 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That's my 24,000, 0. And I've already got a line here. Let me go grab it. See if I can grab it. There we go. And we'll line it up here pretty close. Let me scoot this down here. There we go. All right. And the equation of this line is the x plus y less than or equal to 24,000. So x plus y less than or equal to 24,000. And I can pick 0, 0. It doesn't go through the origin, and 0 is less than or equal to 24,000. So I'd be shading underneath that line, close to the origin. X minus 3y is 24,000 and 8,000. So to the right, 24,000, up 8,000, 2, 4, 6, 8. Right about here is 24,000, 8,000. and the origin. So let me go grab this line, slide it over, orient it the right way. Here we go. I'll put that through there. I'll grab this, make it go over here. Here we go. And grab this, if I can, make it go over here. All right, good. And this, oh wait, I gotta grab it up here. This is not exactly lined up yet. There we go. All right, and that's my 24,800 point. We need to find this intersection right here. And again, you'd set them as equality. You could do Cramer's method. You could pretty much observe this one. 2, 4, 6, 8, 10, 12, 14, 16, 18, 2, 4, so 18,000, 6,000. Does that work? 18,000 plus 6,000 is 24,000. Yeah, 18,000 minus 3 times 6,000 is 0. So yes, this intersection, our scale's not too bad. That is 18,000 and 6,000. And once again, I'm shading. I can't pick 0, 0. This isn't exactly going through the origin. Let me fix that a little bit here. I don't know why it does that. Let me just use my finger here. Click on this. There we go. Want to go through the origin. Okay. Good. And this is definitely 18,000, 6,000. I can't pick 0, 0 for my x minus 3y greater than or equal to 0 because 0, 0, it goes through 0, 0. So 2, 4, 6, if I pick 6,000, 0, 6,000 minus 0 is greater than or equal to 0, so I'm shading this side of it. So I would shade this side of the line. X greater than or equal to 0, I would shade above the x-axis, or that's y greater than or equal to 0. X greater than or equal to 0, I would shade to the right. And then this x plus y less than or equal to 24,000, put 0, 0 in, that's true. So I would shade underneath it. And you have this triangle here. This is my feasibility region. This triangle. So all I have to do is check the origin. I check 18,000, 6,000, this point right here. And I check this point right here, 24,000, 0. So that's what I'm going to do. You take my revenue, 0.6 times, let's do the 18,000, 6,000. 18,000 plus 0.10 times 6,000. 0.6 is 6/10. 6/10 times 18,000. 0.10 is 1/10. 10 100ths or 1/10. 1/10 times 6,000. This 10 takes off one of these zeros, and 6 times 1,800 is 0, 0, 6 8s are 48. 6 times 1 is 6 plus 4 is 10. 10,800. And 1/10 of 6,000 is 600. So 10,800 plus 600 is 11,400. 0, 0 is obviously not the one. If you put a 0 in and a 0 in, you get 0. That's no return. So let's check the other one, the 24,000, 0. R equals 0.6 times 24,000 plus 0.10 times 0. And that's 6/10 of 24,000 plus 0. 10 takes off the 0 here, and 6 times 2,400 is 0, 0, 24. 2 times 6 is 12 plus 2 is 14,400. Actually, this one wins, and I mentioned this in class. Sometimes it's good to dump all your eggs in one basket. Sometimes it's good to make this big investment here. Before we couldn't do that because we had limits. Remember the first problem, the second investment had to be more than 10,000 or something like that. This one had no limits, and in this case, all $24,000 should go in the AAA bonds, which is a little counterintuitive because the AAA bonds only yield 6% and the B bonds yield more. But I can invest 3 times as much, or my amount invested in my AAA bonds has to be 3 times or more than the amount invested in my B bonds. So my B bonds were constrained a little bit because my AAA bonds are going to be always 3 times as much or bigger. 24,000 is all of it in the AAA bonds is the best way to go in this case. All right. So look at that problem, and then I'll type out the problem for the simplex method and give you a video online that you can look at for the simplex method. All right. Take care.